Welcome everyone. Very nice to see all of you here physically and also online, obviously. That's a good thing, I think, with the post-pandemic that we do these hybrid events, I think. My name is Andreas Larsson. I'm a Deputy Vice Chancellor here at BTH and also part of the supervision team for Jenny with Tobias, Larsson, one of the guys with the laptops over there, and Johansson, Askling, who's also running the technology today for us. Christian, you will admit everyone that joins there. So the title thesis, please take a copy if you haven't taken one already. Innovation Engineering in Practice, Breeding, Exploration and Exploitation in Large Manufacturing Incumbents. For those of you joining us online, please let us know via the chat if you experience problems with the audio or video. I think it should work. We have tested it, but you know how it is when you actually run things, that things might happen. But we'll fix it. In the event of an emergency, we have the exits, emergency exits in the back here, but you can obviously also go out here, and then you see the yard out there. There are emergency exits there as well. Then we have bathrooms over there. So for you that are online, you will figure this out yourself. I know. Just wanted to, Anna, if you can join here as well. I want to introduce today's main actors for this event. First, of course, I'd like to welcome the respondent, Jenny Elfsberg. It's a big day for Jenny, obviously. We've been waiting for this. You've been waiting for this. Maybe a bit scared, but that's how it is, right? Yeah. I'd like to welcome the opponent, Martin Steinert. Martin is a professor at Norwegian University of Science and Technology at the Department of Engineering, Design and Materials, right? Good. Joining us online from Croatia, you saw him already, Professor Storga from the University of Zagreb. He's a professor at the chair of Design and Product Development at the Faculty of Mechanical Engineering and Naval Architecture. Thank you for joining, Mario. Yes. Also joining us online, we have Louise Møller Haase from Aalborg University. Louise is an associate professor at the Technical Faculty of IT and Design. So if you say something as well.
Hello. Nice to see you.
We have her. Yes, very good. Thank you very much. And then we have here, joining us here in Karlskrona, I want to welcome Anna Runnemalm from University of Skövde. Anna is an associate professor in mechanical engineering at the School of Engineering Science. And again, welcome to all of you in the audience, online and here physically. We appreciate that you are here, obviously. I want to tell you a little bit about the procedure. Some of you have been through this many times, but it's different in different countries and also at different universities. So I'll run you through it. The respondent, Jenny, will give about 40-45 minute presentation of her work. After this presentation, we will have a 10-minute break. So there's time to go to the bathroom and get some refreshments and so on. The opponent, Martin Steinert, will then lead a discussion with the respondent. And there's no time, I want to say, there's no official time limit, formal time limit. This could go all day or all night. And that's the way it has to be. Usually it doesn't, but we have to prepare for it. Hey, Ola. So we will take breaks in the case that it runs longer, but also feel free. It's not so formal that you can't leave and go out and go to the bathroom or grab a glass of water. So feel free to do that if you feel you don't need my permission. After that, the time for the examination committee members to ask their questions. And then we open the floor to the rest of the audience, both here physically and online. After this, the examination committee will convene in another room. During that time, when they discuss and then come to a decision, you just have to hang around if you want. Obviously, the act as such is over, but you might want to hear the result. So then you hang around. That's pretty much this. And then when they have reached a decision, we will rejoin in this room to announce the decision. That's the way it works. And with that, let's open the act. And the floor is yours, Jenny.
Thank you.
So thank you to all of you in this room and on Zoom. I'm so happy that you are here with me on this, for me, very important milestone in my life. I'm about to conclude my research journey as a PhD student, and I'm the author of this book. It's a pretty heavy one. So just to give you a quick understanding of what's in it, I decided to make a fake book review. So I pretended to be a book reviewer of some glossy magazine and wrote this. In a world where change is constant, manufacturing companies face a thrilling challenge: how to stay relevant and thrive. Jenny Elfsberg's newest book, Innovation and Engineering in Practice, offers valuable insights and approaches to conquer this task while being both thought-provoking and inspiring with relatable examples from her studies. Discover the power of innovation and engineering, a groundbreaking approach that combines creativity and practicality. This book reveals how big manufacturing companies can not only improve their existing offerings, but also revolutionize the way they create value, and if well played, gain a competitive advantage. Imagine shaping the future with intention. The concept of intentional product service system design becomes your secret weapon, an organized way to build upon your current strength and embark on a transformative journey. But this book doesn't stop at theories. It provides step-by-step guidance how to ignite innovation within your company. You learn how to bridge the gap between exploration and exploitation, making ideas a reality, ensuring most promising innovations have fast and a lasting impact. In my opinion, as a book reviewer, this is not only a book, it's your ticket to adapting and thriving in a fast-changing world. Embrace the challenges, inspire your team, and secure your company's future. Are you ready to unlock the door to the future? Get your hands on this must-read guide today and join the ranks of forward-thinking manufacturing companies. That was all fake. So let's now go into the details. And now I'm going to do a more traditional presentation of my thesis, going through the research background, the research questions that I have posed, the research methodology, and why I have selected this one. Just a few of the theoretical concepts that I'm building my research upon. And then I'm going to go into my findings. And then finally, a closing remark. So you will know when to applaud, or maybe the applause will help you to wake up. Let's see. So my research background. For the most of the time that I have been a PhD student, I've been a full-time employee at a company called Volvo Construction Equipment, Volvo CE. Volvo CE goes back to 1832 and the city of Eskilstuna, about 450 kilometers north from here. Volvo Construction Equipment has a long history, extensive know-how, and global presence, and a long-standing success to build upon. And this company is just like many other large companies in the world facing disruption now because of technology advancements and societal development. And this company can choose to lead or follow. And I'm going to show a case to you where I think Volvo took the lead. Meet Gravel Charlie. This is the world's first articulated hauler, and it could carry around 10 tons of materials. It was put in production in the 60s, and articulated haulers are still a big part of Volvo Construction Equipment's business. Meet the A60. This is the largest articulated hauler on the market and the latest in a long series of articulated haulers that have come out of Volvo. And this machine, it has long service intervals, fast cycle times. They have an operator experience that would make like everyone wanting to be an operator. And it has the lowest cost per ton, carrying 55 tons per load. Until now. Now we have technology advancements making electrification, automation, digitalization, and connectivity happening, and things can be done in another way. This is a conceptual machine called HX02, today known as Tara. You can search online. And this machine can carry 15 tons. And this machine outcompetes the A60. Of course, not on its own. It needs to have some team members that replace the big one, from the elephant to the ants. And these machines are not yet completely autonomous, so they need someone to supervise and control them. This is a good example, in my view, what is happening to big, old, successful companies that are dealing with disruption due to technology. So large manufacturing incumbents, that is a very simple word that we all use in everyday practice, right? So large, I think we use sometimes. And when I talk about large here, it's not small companies, it's not medium companies, it's large with like 10,000 or 100,000 employees, really large companies that are manufacturing products. So they are making physical products. Incumbents, that means that they are the ones that are in power or having a dominant position today. So we've heard it about presidents, but it also works for companies. So large manufacturing incumbents, we all know that concept now. And I put one of my favorite sites within Volvo Construction Equipment there, the Changwon site in South Korea. Large manufacturing incumbents of all kinds in all industries, they have a long history, many employees, as I said, and a stable and substantial revenue generation to protect. They are recognized as industry leaders with long-standing presence and significant market share. And because they have been around for a long time, they have a wide range of products and services that they are offering to the customers. And they invest heavily in research and development to continue to stay competitive, to exploit what they already are doing and make it better. They have a global footprint with corporate campuses around the world, as well as production. And they have focus on operational efficiency and maximize productivity. And these are the companies that are the context of my research. So over to my research motivation. So I have been working for 22 years within Volvo Group. Volvo Construction Equipment became part of Volvo Group in 1950. Forgot to say that before. And I also been in other parts of Volvo Group, so not only Volvo C. And I have been working in advanced engineering, industrialization projects, and product maintenance, where you take care of stuff that happens for the customers in the field. So mainly within the research and development part of the group. I have also, quite surprisingly, a research interest, but only because I've had a long-standing close collaboration with the academic partner, ETH. So these colleagues awakened my research interest. I also have had, ever since childhood, and maybe a bit more enhanced the older I get, and also as a parent, a strong desire to create a positive impact that will benefit future generations. And last but not least, I am passionate about empowering engineers and engineering teams to shape the future, because we need it and we need them to do it. So in my book, you will find this quote by Theodore von Karman. The scientist describes what is, the engineer creates what never was. So who was this? This was a pioneer in wind tunnel experiments and development to build new knowledge on aerodynamics and fluid dynamics. And I first learned about him because I've been a plumber, gliders pilot, engine developer, and also a vacation time sailor. So yeah, aerodynamics is very interesting. But this quote, what he meant, he was a great scientist, but he really wanted to solve real world problems. He wanted to implement the knowledge and make a difference. So he preferred to be called an engineer. I don't have the quote because I want to talk about the polarization between scientists and engineers. I don't think we should divide it in the two, but I love that quote because from my research experience, I think the sentence is incomplete. The engineers create what never was if we only enable them, train them, let them, guide them, support them, trust them, set them free. And that's my research motivation. So do we set them free? I just wanted to quickly go through a starting point of my research journey at the company. So this is far back. I'm not saying this is the situation in the company today, but then we asked employees around the world, 11 different R&D sites, to tell us, so how does it look? So the corporate culture did not foster innovation. There was no process for innovation. Leadership had no interest in innovation, and leadership was lacking competence regarding innovation. It was even said that innovation is the opposite of quality, and quality must come first. The development process was linear, prioritizing risk-free increments and considering new content as an increased risk. We don't want new content. There were no resources allocated for innovation, and engineers weren't encouraged to innovate. And let me be clear now, I don't talk about all innovation. Of course, a continuous incremental innovation that is part of keeping your products up to date, that was embedded in the exploitation-oriented processes. But anything outside the core, that was not taken care of back then, which of course triggered some motivation for me as well to fix this problem. Now, I'd like to bring you back to 2009. This is 2009, November, in Eskilstuna. And my team, the emerging technologies team within all the construction equipment, 20 research engineers across the globe, with the responsibility to explore emerging technologies and develop promising new concepts. We invited our colleagues to a knowledge sharing seminar. And we were inspired by the space race in the 50s, 60s. I think we all know about that one. So there, some of us might remember, or at least I, because I prepared, remember JF Kennedy's famous speech about the moonshot. We choose to go to the moon, not because it's easy, but because it's hard. Because that goal will serve to organize and measure the best of our energies and skills. He continued, we choose to go to the moon because that challenge is one we are willing to accept, one we are unwilling to postpone, and one we intend to win. This appealed to the pioneering spirit of the American people and made them feel that they had the ability to overcome immense challenges, explore new frontiers, and shape their own destiny. And we thought, maybe this can also work for Volvo CE's employees. So we said, we choose to go to the moon with our machines. And if you want these machines to work on the moon, it's far away and it's a very different environment. They need to be reliable, 100% availability, zero emission solutions. For the reason there is no oxygen, but also because why should we spread emissions? 10 times or more higher energy efficiency, no accidents. It's far away, so we would need them to be autonomous or at least remotely controlled. And in order to get to that, we definitely need to be number one in innovation in our industry. This was November 2009. Now, join me on a time jump into 2016. Under the leadership of Marty Weisberg, Volvo Construction Equipment invited to this event called Exploration Forum. There we invited customers, partners, suppliers, media, and also employees to share how the future might look like for our industry. We presented our 000 vision with 0 unplanned stops, 0 emissions, and 0 accidents. We also presented technologies, but we presented them in action by actually working prototypes, showing how a fully autonomous and a fully autonomous wheel loader and hauler were working together in a specific use case. We demonstrated a hybrid wheel loader and a battery electric hauler, the one I showed before, working together. And we also demonstrated the electric site solution where we could show how we could zoom out from the machines and demonstrate this energy efficiency. So besides the 000 vision, we also had this 10 times higher energy efficiency, because that will help us to get the innovation to happen on a higher level. So we could eliminate losses on the machines in the process and even rethink the entire process. And the electric site research project that was done together with academia and with customers and partners. And we eventually proved in operation on a quarry site, a job site in Gothenburg, that we could reduce CO2 emissions with 98%, 70% energy cost, 40% operating cost, and showed the potential of having 25% lower cost of operation, total cost of operation. But these were prototypes, not commercially available, none of them. And it was a result of long-term research collaboration with academia and customers and other partners. But the significant improvement, that's at least what I would say, is disruption to the industry. Enough about the research background. Over to my research questions. The first one, how can large manufacturing incumbents strengthen their innovation capability? Research question 2, how can exploration be institutionalized, guided, and led in large manufacturing incumbents? How can we bridge between exploration and exploitation in large manufacturing incumbents? And how might the bridging between exploration and exploitation help large manufacturing incumbents to shift its business orientation from products to product service systems? Before we're done, I'm going to present to you some of these how. The research methodology I needed to choose needed to be flexible and provide structure that I can go back into now and then, because I have been a full-time employee at a company, an industrial PhD student. And sometimes work doesn't allow that you do your research. So you need to be able to come back to the structure and still know that this is the research I'm doing. And with that background, I decided to go for design research methodology. So I could solve the problems I wanted to solve in a structured and design-oriented manner. So I could go through these different stages and allow myself to iterate and to go back and maybe reconsider what was really the goal with this study. Did I get it wrong? So this has been very, very instrumental to my long research journey to be able to go back into this. So in design research methodology, there are 4 stages. So the first one, it's kind of crucial that you know what you want to study. So the research clarification is about understanding, what is already out there, all the knowledge, what is the problem I want to address. You can easily jump into studies without knowing what you want to look for if you don't do this work well. But you can also, thanks to this structure, you can also allow yourself to get it a bit wrong and then go back and iterate so you get it better. And then for the following stages, descriptive study 1, it's understanding the current situation. prescriptive study is to define the desired situation and see if you can find ways to support to move in that direction. And then in the descriptive study 2, you will test and evaluate whether these ideas you have for how to support the move are useful at all. And how you design the studies, it depends on what you're looking for. So you should, of course, you want to work with different types of data because especially for me, because it's have been a lot of qualitative research, talking to people. So then it's really good to do triangulations. You have different perspectives, different sources of data, so you can feel a little bit more confident that this is not an anecdotal story. It is really thought through from different perspectives. So I would recommend you solve any problems, use design research methodology, but it also works for my research. So now, too few theoretical concepts I want to go through with you. I picked 4 of the really core ones that I build my research upon. It's definitely not sufficient, but this is what I chose. So first of all, you have already heard me talking about this explore and exploit and organizational ambidexterity. So ambidexterity, I think we have heard the word, many of us. If you are good at handwriting with both your right and your left hand, I'm definitely not, but then you are ambidextrous in handwriting. And also if you are a very good soccer player or any kinds of sports and you can work with both sides, that's also ambidexterity. But when you work within a large manufacturing organization and you talk about ambidexterity, it is about being really good at exploiting what you are already doing. So to continuing developing what you have already started your company with and work on that. And then exploring how can we provide value in new ways to our customers or other customers. So explore and exploit. So I'm not going to go through all of these, what I put, but you would say that they are very different in nature. So when you are exploring, you need to be open-minded and curious, while when you are exploiting, you want to stay within the box and develop stuff that you can produce in your existing factories. You want to build on what you already have. And another thing is that successful exploration requires that you are open for that your first idea might be wrong, while when you are working with exploitation, it's really good to box it in with a requirement specification or like making sure this is the box within which we are working. So organizational ambidexterity, they are very different in nature and both necessary for a company's longevity. So I don't use always the word ambidexterity. I refer to both and leadership. So when I say that later on here or in our conversation, it means that being good at both exploration and exploitation. And that is a very important baseline to my research. Product service systems. This is also a concept that has been around for a while, and this means that if you have a physical product and then you integrate it with services, so intangible offerings, and you combine them, and then you solve that as a single offering, that is the product service system. And this can be a good way for companies to strengthen their relation with their customers, to go more from transactional sales to being connected to the customers longer time. It can also enhance experience for the customer, that they get more experience from the offering from the company. It is also necessary, in my opinion, to enable sustainable development and resource efficiency, and eventually the circular economy, that you can connect it like that. So if we talk about the pure product delivery, I put, since I have my kids in the room, I put the Bluetooth speaker because that one you can just purchase and you don't forget who sold it to you, and you don't really care about the brand that much, but it needs to function. So that's the pure product. And then, we have the pure services, and that's a value that is only intangible. So let's say maybe, I could have said maybe massage or something, but I chose to put Spotify here because you don't really want them to care about what hardware you are using. You want to stream to all your devices, preferably all your family's devices. So these are very separate pure services and pure products. And what the industry and the company I've been working in now is how they came from a pure product sales and they have moved towards these product service systems. So building on their products that they have been good at doing for years, they add service content. And this can be done in different ways. So if you have a product-oriented product service system, you have that transactional sale anyway, but then you add services to it. So it's going to be very clear that you base it on a product. So it could be a car sale with a service agreement, or a car lease even that you have on come. And then we have the use-oriented product service system. And my favorite one in my everyday life is the voice scooter that I claim I enjoy walking to the train and from the train every day. But sometimes I'm too tired, and then I can use this voice scooter. I just scan it, take the ride home, and forget about it. So that's it is a product and it is a service, and it gets me home, and I can forget about it. Result-oriented product service systems, that's when you pay a premium to get the quality, the results, whatever kind of performance you want from your product service system. So one of my favorites, and maybe also because I have Ola in the audience, the airlines, they want to have the thrust and the quality of the jet engines when they are transporting us to our vacation places or business trips. And then they can have this type of result-oriented service so that they will know that they will get the people where they want to be. That's pretty convenient for us as passengers. So next concept I want to go through is this double diamond. The double diamond describes how the exploration process looks like. And it starts with an initial problem statement, right or wrong, you need to start somewhere. And it ends with one solution that you can test on your targeted user. In between that, according to the double diamond, you have two diamonds, which means that you first diverge. So you expand the problem space from that initial problem statement, and you try to find the right problem to solve. So it doesn't really matter if the first problem statement wasn't right, as long as you know what context you're moving in and somewhat what the aim is. You can research, you can benchmark, you can go in and understand the different users' needs and understand the context. And then at one point, when you have been generating more and more understanding about the problem, you need to decide like it's time to converge. So now you need to stop to explore. It's super fun to just build knowledge, but at one point you need to shift and you need to decide, okay, so what is the problem we're going to solve? And then you do the same for the solution space. So again, you diverge. You can prototype as many learning prototypes you have time for. But at one point, you need to converge. And through these both diamonds, you are going to use questions, different kinds of questions to make sure that you are focusing on the right thing. Because of course, if you're too creative, you might get far out from the main problem. So this double diamond, it has two occasions that are super painful and very, very important. And this is the groan zone, not the groin zone, that's something else, but the groan zone. That is where you go from this fun, understanding, learning, building knowledge, and you need to decide, you need to shift. And there it's painful because you have so many great ideas, you have so much knowledge and different perspectives, and you need to shift and go back to, you know, agree on something. But that pain should be embraced because it's super crucial to get the best outcome. The last theoretical concept I wanna talk a little bit about, and it's not because you're so this is the triple loop learning, and this is mainly from studying student teams, but I think it is valid for any type of exploration work. So a team that are on this exploration journey, they acquire their knowledge in 3 simultaneously occurring learning loops. So the first one, that is really the one that we usually get documented from projects. So that is what is explicitly learned and documented quite often with quantitative data. The second loop is when and why they learn. And this can be, maybe they do simulation, maybe they do experiments, maybe they build something that breaks, you know, how, when do they learn and why do they learn that? And how we can see this is actually to look at the prototypes or the reports or like whatever they do that is more intangible. So you won't see it like explicitly documented, but you can see it through the journey. Yeah, the prototypes, the tests they have been doing. And then we have the core of my research and many others before me. So I'm building upon an extensive body of knowledge from researchers before me. But in loop 3, this is the team on their own, how they are learning together. So in the other 2, they can be dependent on interaction with, well, in a school situation, that would be their teaching teams and all that, and in the industry, it would be sponsors or decision bodies and all that. But in the learning loop 3, it's about their journey together. How do they work with acquiring knowledge and using the knowledge to get further? And this is so interesting. So let's talk for 3 more hours about that, but not now. Because now I'm going to go through my findings. And I'm going to do it in this simple, basic way. I'm going to remind you about the research questions and tell you about what I found out. So research question 1, how can large manufacturing incumbents strengthen their innovation capability? It's easy. It's only 4 components. So I suggest that you establish an innovation capability framework. And of course, in my book, you find this beautiful yellow thing, but that was in my context, in my company, with my colleagues. I'm not saying it's irrelevant, but I would say this is not a pill to swallow. Establish your innovation capability framework. And then this measure progress. And this measuring progress, of course, we all want the perfect scientifically proven way of measuring, but forget that, measure, because you want to promote the behaviors, you want to diagnose whether are we moving at all in the right direction. You want to experiment, are the metrics right? If you have a metric that doesn't change for several cycles, maybe that metric is completely irrelevant. And then, of course, with the measuring, you can actually reflect together with leadership and together with your colleagues. So are we building innovative capability? The third key component is to, within your large manufacturing incumbent, build a network of innovation ambassadors, part-time employees on the different local sites, but also globally connected, so they can together drive the development of the company. This is has been very, very instrumental to our journey. And then, of course, infuse habanero peppers into your tequila for a good margarita, or infuse organizational ambidexterity. And what I mean with that is that there are different ways of having organizational ambidexterity. And I'm not suggesting that any way is wrong, as long as you also infuse and make sure everyone in the company understands that exploration and exploitation are equally important, and how they are important, and how they are diametrically different. On my second research question, how can exploration be institutionalized, guided, and led in large manufacturing incumbents? Oh, I wish I had written that question a little bit easier. So the concept of innovation engineering, building on previous definitions of innovation engineering, I've been continuing on building on this because it has been so useful to just have this as a different approach compared to the exploitation ways of working. So innovation engineering, have you seen the movie Kon-Tiki from 2012? That's what I would say about innovation engineering. This is a collaborative journey, an expedition, where a team works closely together to tackle these open-ended, ambiguous, complex problems. And they build knowledge together that might lead to radical innovation. It will always lead to knowledge, shared knowledge. And they join forces on the journey. And when they do this, they will develop knowledge that can lead to many different ideas for solutions. So what's happening during the journey is useful long after the first prototype is tested with a targeted user. And all these innovation engineering journeys, they have this start point, that is, you need to start somewhere with an initial problem statement in a context, and the end, that is something that you can test with a user. But every team have their own unique journey. So you cannot have a very strict process on how they should go through it. But you need to work with them. So for this, I have two tools that I would like to suggest that you, as a supporting cohort, that would mean teaching teams if you are in an academic setting, and in a company, it could be like the project sponsor and some of other colleagues that would guide the team on their journey. So you would walk the path by their side, not telling them how the path looks like, because that's their journey, but then you will follow them and see how are they experiencing the journey. And then you can recognize what we've seen in my research is that there are some patterns that are reoccurring. And then you can nudge them as needed, but nudge, you don't want to disturb their loop 3 there. So for example, in the start, we have learned that make them get to know each other for real in the beginning. And when I say for real, I don't mean that's a cozy, let's have a nice kickoff with lots of beers or anything. It's about understanding the different skills, the different preferred behaviors, like learning styles, and really understand who are we in the team and how can we utilize our differences as strength. And then when it comes to divergence, preserve ambiguity, as it says. And if it is the problem space, you need to get out there, go and look and find what is it really this problem is about. And when it is about the solution space, you should have them prototype to learn, and don't think that the first prototype is your perfect one, because that will definitely not be true. And when it comes to the convergence, and that's where we want the team to continue to treat each other well and utilize all the strength and have this connectedness solid, and so on. The other guiding tool I suggest is this inspired by the hunter-gatherer map or model. So you have this map, just like you walk with the team on the journey, you walk with the team on their prototyping journey. So here you can, as a supporting cohort, draw up. So the first solution vision the team is building after they had their initial problem statement. Put that up there on a white paper, and then you will follow them when they are doing their prototypes to learn, and they will, because this is a good team, so they will continue to prototype and build knowledge together. And at some point they might say, oh, our first solution vision wasn't what we wanna go for. So they're gonna shift a little bit, and they will continue with the prototypes, finding new solution visions. And maybe at one point on their learning journey, they will pivot dramatically and then continue to build a prototype all the way to the final prototype that they will test with the targeted user at this point. So for one journey, you will have the starting point and this tested prototype with many, many learning prototypes in between. And this is something that you can find a lot more beautiful picture in the book made by Christian up there, following a team some years ago. So intentional PSS design. Let me now see so I don't forget to say something. So here I build on two existing concepts found in literature. So it's the MOVE workshop by Carlton, Larsson, and Bill in 2011, and also an updated discourse in PSS design by Lugnet, Eriksson, and Larsson 2020. So both of these, they have these components of understanding the now, envisioning the wow, like the wanted future, and then figuring out how to get there. So building on that. And then when it comes this PSS design by Lugnet, Eriksson, and Larsson, it is considering all levels of a system at the same time and being able to zoom in on the job to be done or the job that is being done, but also looking on the process in which that job is being done, and also the system in which this process exists. So it looks like this. Current actual level, the job that needs to get done, that is an easy one. And then you zoom out. So in the process, this job is interacting and interdependent with other things that are happening on the operational level. And then on a system level, this operational level is existing. And then in the current business model, you can actually describe that. For the future, we can also describe that because we are all equipped with imagination and we can all anticipate the future. It might be wrong, but we can have some ideas and some plans how we want the future to look like. So then we describe the system level, the operational level, which one we are targeting, and then we can define the future job that needs to get done. And in the company I've been part of, large manufacturing incumbent, it has been a lot about this. What kind of digital technologies can help us to make the shift? But for sure, this model could be used for any kinds of technologies that are enabling. Research question 3, how to bridge exploration and exploitation in large manufacturing incumbents. So the need for the buffer. So I'm going to show you now how it might feel if you are working with exploration within a large manufacturing incumbent and you are going to a meeting to get funding and resources for your project. So it's not always easy to explain what you are doing in the small pocket of the company that is doing the exploration projects at least before you have infused them with dexterity. And then these executives in the companies, they are really, really good at optimizing the company's performance. So they made decisions that are showing results in like quarterly reports and all that. And then you come with something fuzzy, dreamy, fixing a user's problem that you have that has nothing to do with the current core of the company. So this can feel like this. And in my study, one of the respondents in interviews I made, he said, your role is to connect and translate for two sides that cannot understand each other. That doesn't sound bridged at all. So my suggestion is that we should all hire Elastigirl from the Pixar movie from 2004. You might not have seen The Incredibles, so I will just quickly tell you who this lady is. So Elastigirl has incredible superpowers. She's elastic. So she can stretch her body to different sizes and change shape. She's strong, she's durable and agile. She's also a mother, and therefore she can multitask, and she's used to being pulled in many directions. And I think this really explains what the buffer role in a large manufacturing company incumbent is. It's just that I don't mean, it could for sure be handy if someone is physically elastic, but I talk about the intellectual elasticity between explore and exploit. But we cannot rely on only Elastigirl or the buffer, because that will break that person. The bridging also needs to be done from the top. So this both and leadership, it needs to come from the top with how they communicate, how they prioritize, and how we walk the talk of being ambidextrous. Also, the exploitation side need to have this both and leadership. For sure, being really good at exploitation makes it hard to also focus on exploration, but at least some understanding the importance of the two. We can expect that from leaders, I think. And then from the exploration side, even though we have the buffer, and in the future we might not need the buffer, the exploration side need to transparently show the rest of the organization what are we doing and why are we doing it, and invite and include the rest of the company, because we don't want exploration to be something that we just do on the side that never reach the customers. So back to my intentional PSS design picture before, I suggest that you can use it to bridge in the company. So if you separate these, you will have the exploitation side on the left and the exploration side on the right. And you can ask people within the exploitation side to explain the current actual level, the current operational level, and the current system level. Of course, you can work together, but the exploitation people in the company, they will understand this and they will be wanting to be part of that. And then the exploration side of the company and others that will engage in that, they will happily describe envisioned future, maybe several scenarios, because we never know what the future will look like. And then together, as the bridge, you together move from the now to the wow, from the current to the anticipated future, and talk about how the system needs to change, how processes need to change, and how the actual job needs to change. And here, this can be a living process, because technology advancements will change what is possible. And also, we don't know, we have climate change, we have other changes in the world that will also impact this. So this is my first bridging approach proposal. The second one, here you visualize all your offerings, existing offerings as green balloons in a graph. So the green balloons mean green on the market, where this on the y-axis would say how much of the market does it have, and then the size would say some kind of value, revenue generation, or maybe in the future we want to measure in many other ways. But it's about the value of the offering you have on the market. And then you take exactly the same for your new promising unproven concepts and represent them in the same manner. And if they are red, we know we need to invest more knowledge building there, because it's too much unknown about how they can be put to the market. And they get yellow when they are like almost ready, but we have not yet figured out something. And then at one point, you need to push it to the market. And I would say push it because in a large manufacturing incumbent, it will not be comfortable to just have new types of business models or innovations go to the market. So this thing, I really believe in it for one reason. It has been used. I learned about this one when I was exploring how can you visualize and make this decision transparent for everyone. And I talked to Cheryl Root at Hewlett-Packard, and she used this together with her colleagues in the 80s when they shifted from selling their printers to solving customer problems. That's how they phrased it. But I made it a bit simplified. So in HP, this is not documented anywhere. It was called the Wonder Bread model. And I simplified it a bit. They had it digitally, so they had a lot more components in it. But I think this tells about how you could shift your company away from looking at your products and seeing our company's long-term presence in the industry as a problem solver or a solution provider. So the last research question, how might bridging help shift from products to product service systems? Yes, I have already talked about all of this, maybe not the last bullet. Infuse the organizational ambidexterity. Make innovation and engineering process and practice part of your core. Apply these innovation and engineering tools. Well, I have some suggestions, there are others. Apply bridging approaches. I like the ones I suggest. And then take a digiphysical approach where you use both your physical products and contextual data already from the early days of your design and through the solution's entire life cycle. And in the future for circularity, this is going to be crucial. And then, ta-da, future proven. 4 aha moments on my journey. It's very hard to be a PhD student, especially when you're as old as I am. But there are also moments that are very nice, like the aha moments when you, we must measure to gain traction. We learned that in our research and definitely also in the practice. And once we realized the measuring with using the method I described there, we gained a lot of traction in the company. The second aha moment was when we looked at all the rich data we had from all the students, and we saw the best teams have similar journeys. They are equally unhappy in the growth zone and so on. So the third aha moment is the explore and exploit gap. In the company I was part of, this was a big frustration because, you know, when you explore and you come with radical innovations that don't reach the market, it's actually a waste of the company's resources. And also people get quite frustrated and demotivated. And when we realized, there are other large manufacturing incumbents in completely different industries that are telling the exact same story. That was, well, that's bad, but that was a relief. It wasn't our company that was broken. This was a systemic problem. And the final one was, of course, when after reading so much literature, after looking for solutions and sitting down with Cheryl Root and learning that, we had it, we did it, to visualize how you choose what you put in the market without looking at the physical product where you came from. That was a big aha moment. So this is my closing remarks. So wake up. In the book, you will find this burger, and I don't think this is very research beautiful, but it's really beautiful to talk about it when you talk with large manufacturing incumbents about how to fix their problems with getting innovations to the market. So this burger is a metaphor what how you know your company, if you have a large manufacturing company, globally dispersed and all that, you can draw your organizational chart with different functions and different levels and all that. And if you would look at, that's also how you construct a burger. But a really super delicious juicy burger, you need to have it cohesive. It shouldn't fall apart. So it needs to be, all the different components need to be together. And that's why I have been using this burger quite, successfully in my conversation, at least. So the top one is about the top level of the leadership. It's kind of easy. I know it's not easy. I'm sorry it's not easy to be a high-level executive. I'm not saying that, but there is a lot of research and there is a lot of consultancies. You can buy loads of support to be a good both and leader on the top. And then if the bottom one would represent, it doesn't matter really if we talk about the innovation and engineering or any engineering in the company, that can also be quite easily explained, or, and I think also the exploration process it is systematic and it's structured. It's just very different from the linear exploitation, but kind of easy. But then all these other parts that you build into your burger, into the organization, also with the different layers and the different roles in the companies. If you build your own burger or your organization in that way, you can be intentional, you can be adaptable, you can be ambidextrous, and you can be future-proof. So make sure you are, it doesn't fall apart, your burger. And I think this is so beautifully simple, but it is simple. With that, before Andreas takes over, thank you everyone for listening, and thank you to BTH for having me, and of course my colleagues at the mechanical engineering department. Let me feel part of the team, even though I'm just here once in a while. Volvo Group have been very instrumental, and especially the colleagues that have been supportive or questioning my research, equally important to this journey. The KK Foundation, who has funded the research profile, which I've been part of. And yes, of course, all of you on Zoom and in the room, thank you all. This was so much more fun than practicing yesterday evening in front of the mirror.
Thank you.